Hello guys, welcome to Embedded System. This is a quick video regarding the pin diagram and the architecture of an 8051. So let's get going. Yeah. So this is 8051 is a 40 pin DIP package IC. It's having 4 ports. Each port is having 8 pins, or you can say 8 bits. So we have total 32 input output pins available for 8051. So let me indicate the ports for you. This is port 0. This is my port 1. This is my port 2 and this is my port 3. You see, only port 1 is dedicated GPIO, that is general purpose input output pins, is while all other ports, that is port 0, port 2 and port 3 is multiplex port. What is by multiplex is a same pin can be configured for different functions. So as you see here, port 0 is having a multiplex function as an address bus, which is having AD0 to AD7, whereas for port 0, and for port 2 it varies from AD8 to AD15. That means we have a 16-bit address line by combining port 0 and port 2. So we can interface a memory at port 0 and port 2, and this pins, which is nothing but external access, address latch enable and program store enable, can be used to access and control the external memory. Along with that, you see the port 3 is a multiplex port with different functions. If you see this, RxD and TxD is a serial terminal available for 8051, and it is at port 3.0 and pin 3.1. We have two external interrupts, INT0 and INT1, available at pin 3.2 and 3.3. We have two timers, timer 0 and timer 1, available at pin 3.4 and 3.5. We have a write signal at 3.6, which is used to write into external memory. We have read signal at pin 3.7, which is used to read the external memory. We have ground at pin 20 and VCC at pin 40. The supply voltage required for 8051 is 5 volt. Lastly, we have two dedicated fins to connect the crystal, which provides the clock cycle required for 8051. So this is about the pin diagram of 8051. Now let's move towards its architecture. You see, the architecture of 8051 is quite simple. You see, it is having an 8-bit ALU which is connected to accumulator and register B, which mostly stores the contents of the operands. Then the output is also connected to PSW, is called as program status words. It's having different flags, and the flags change based on the result of operation in ALU. Along with that, we have two 16-bit registers, a program counter and DPTR, which is data pointer register. Along with that, we have 4 kilobytes of RAM, 4 kilobytes of ROM, and 128 bytes of RAM available with 8051. Along with that, we have 4 latches corresponding to each port. This latch is used to latch the data from respective ports. Along with that, we have a timing system, interrupt, timers and data buffers for memory control. Along with that, this block here shows the internal structure of a RAM, which is connected or which is shown here. Now you see, the RAM itself is divided into 4 register banks, that is register bank 0, 1, 2 and 3, and a byte and bit addressable space. Along with that, we have the spatial function registers, namely TH1 and TL1, TH0 and TL0. These four 8-bit registers are corresponding to timer 0 and timer 1. Tmod register is used to set the timers. Tcon and Scon, these two 8-bit registers used for, along with that, SBuffer, SBuff, Scon and Tcon are used for serial communication. P is a power mode control register, and these two registers, that is interrupt enable, i.e. interrupt priority, these two registers are used to control the interrupts in 8051. To program 8051, we should know about the internal structure of 8051. Right? So this class concludes here.